The record button. Hey, everybody. Thank you for coming to the Apps and Tools calls. It's 1:03 Eastern Standard Time, where I'm at. And we're going to have a great presentation from Alex Rademacher from IBM Brazil and the Applied Mathematics School of, and I can't pronounce the name of the school. Alexander, help me out.
Okay, it's Applied Mathematics School of the Getúlio Vargas Foundation. Getúlio Vargas.
The Tulio Vargas Foundation. So he's going to see my Spanish is horrible, isn't it?
Portuguese.
Yes, Portuguese,
Oh,
but
it's
yes.
Portuguese. Well, that's why. That makes sense then. I don't speak Portuguese. So,
No worries.
so he's going to give us a great presentation on the processes he used for working with RDF data as part of the Lattes project. He's going to tell us a little bit about the Lattes project, and we'll have a discussion. I just wanted to take the time to bore all of you with some interesting things. So, I don't know if you guys know who Edward Tufte is, but he is a statistician and professor emeritus of political science statistics from Yale, and he wrote this book, which you may or may not have heard of, called The Visual Display of Quantitative Information. It's pretty much the definitive work on data visualization. Um, so
Come on.
I, I recently
Visualization is
did.
a very new area to say that's definitive work, right? So it's
Um,
should be.
Tufte wrote the book a really long time ago, and so I say it's the definitive work because Kadi Borner, who was part of the VIVO project, told me that this
Uh,
was the definitive work on data visualization. So, and she's
wow.
a world-renowned data visualizer. So I'm just assuming that that's the truth. But I have subsequently, since she told me that, read the book, and then I've heard it from other people, other statisticians, and other. They're like, "Oh yeah, you got to go read Tufte."
I
So
see.
anyway, I noticed that he was on Twitter because I think that somebody I was following him, and I found out the guy tweets like 5 or 6 or 7 times a day, and he like tweets some great stuff that you're like, oh man, this is awesome. So he tweeted something the other day that I just wanted to show everybody, and I think it's awesome. So let me refresh this. So this is his idea of how to improve data tables by taking things away. That was John Corson record. I muted him for a second. So I don't know if you guys can see this. You're watching the animated GIF, but I texted the link in the chat box, but it's just it's a pretty neat HTML5 type animated GIF that shows you how to make a data table more impressive and more impactful, as they were saying. Less is more
Sure.
effective. So I thought that was neat. And another thing that came out is from another tweet is the world still revolves around CSV files, and so I don't know if this group is familiar with lint tools, but lint tools like XML lint um, and Java lint are really tools that were designed to go and clean up code. And then with the introduction of XML lint a while back, it was designed to make sure that your XML that you were trying to ingest as data was properly formatted. Well, somebody came around and Ted was actually telling me that some of these guys were actually involved in the Jenna project, the guys that created CSV lint. So if you want to check your CSV file for proper formatting in before it starts breaking the code you're writing against it, this is a great site. They also you can I'm pretty sure you can get the code for this, so you don't have to use their web tool. But basically, they've got a web tool where you can upload a CSV file and it will lint it for you. And you can also download this code from GitHub, I'm pretty sure, and use it. So just two things I thought I'd bring around to the tools group here. These are two pretty neat things. Definitely if you're a Twitter person, I would definitely follow Tufte because these two tips came from him like last week. And I think I can't remember if it was him or one of the other data people turned me on to D3JS. So that was about it. Hey, I unmuted you, John. There we go. All right. Well, without further, John said RDF Translator, appspot.com. Let me go there. Oh, cool. RDF Translator is a multi-format conversion tool for structured markup. It provides translations between data formats ranging from RDF XML to RDFA to our microdata. Service allows for conversions triggered either by URI or by direct text input. Furthermore, it comes with a straightforward REST API for developers. Oh, pretty neat. That's pretty cool.
I just ran across it today. I haven't tried it, but
no, this is pretty neat. Well, I found that problem there where we were going through a lot of rework on our ingest because it would take a really long time to do ingests, and then we would get to the final stage where we were putting it into VIVO only to hit XML errors, and it was like, we should have linted it beforehand so that we could have corrected it in the program. So
Joe McInerney, the guy who does most of the ingest here at Cornell, has also just added a process to his ingest that kind of validates the RDF and checks to see whether any property that's referenced is actually in one of the ontologies, so that you're not introducing new properties with with these the new 1.6 property names that are like 7 digits long and include a lot of zeros, 4 or 5 zeros in a row, and things like that. There's extra potential for typos. So he found that really useful, and it also, checks to see that that the URIs referenced are valid and things like that. So
that's pretty cool. Is he? Maybe you could
talk to him. It's a Perl thing. He'd be happy to share it, but it's a Perl thing that uses some XSLT stuff, and so it may be. I think it's useful and worth sharing, but there may be other ways to do the same thing in Python or.
Well, what would be neat though is if he could come on and give us a presentation of it and just talk to us about what design decisions he made. Maybe people could get ideas from his design if they were going to build their own.
Yeah, I think Joe would be willing to do that.
Did you hear that, Ted? I'm just taking some notes here. Well, without further ado, while I take that note, let me start handing over presenter to Alexander.
Okay.
Coming at you.
Okay, so show my screen. So are you seeing my screen? How it works?
Do you have Gmail up?
Yep. Okay, so because I don't have any way to see my own screen, how it is showing to you, right?
We can see the screen that you have open with your Safari browser. Right now you have the focus on your inbox for Gmail.
Okay.
And now you just turned off screen sharing.
No.
Now you're back again.
Okay. I would like to see a small window with my own screen, but I don't think.
Do you see right? I don't think you can see the window. It's whatever active window that you're on your Mac.
Okay.
So whatever desktop you're on.
So let's go.
So now you're switching to Emacs, right? So now we can see Emacs.
Okay, so let's start. So the idea was here is just to give some to present what is my current tool set. So what kind of tools I use it to work with the source files that we have here in Brazil, and how we transform that and clean up the stuff to to ingest into our Vivo instance. So currently we have, since our instance is closed, let me use this chance to show for you in what is our current state. So we have already this Vivo installation. It's pretty clean, no customization in the interface, but as you can see, we have already a bunch of data, and this is ingested last week, I think last 2 weeks, and we are now trying to improve a little bit the workflow to be able to maintain this data in an easy way. So the main problem for now is the performance. So the ingestion took me about 8 hours, and I really like to have a better performance on that. But anyway, so let's go back to the file that I prepared to show to you. So that's the idea of the presentation. And what kind of tools I use it. So we use here, of course, Git for source control. I use it to program the code that I most work with is Common Lisp code. So I'm a Common Lisp programmer. And Common Lisp has a bunch of different interpreters and compilers. I use it to work with Allegro Common Lisp. This is a proprietary one, but we also have the SBCL, that's open sources, and ABCL, which is a Common Lisp interpreter and compiler on top of a Java virtual machine. So the nice thing about ABCL is that we can use all libraries for RDF that are written in Java. I also use R, Python, the org mode. Actually, the current file that I'm showing to you is an org file in Emacs. I don't know if you know about this tool, but CWM is a closed word. What's the M stands for? But so this is the, I think, one of the first tools developed by Tim Berners-Lee in the beginnings of the whole idea of web semantics. And I show you what kind of use I have for this tool. Allegro Graph is the triple store that I put my data. Groove is a visualization stuff, and Teed and other small stuff. So let's go for the process. So I have two main sources of data. The main one is the XML files from this curriculum lattice. So what is the curriculum lattice? Lattice is a system, we call him Brazil a platform, but it's actually a web system maintained by the government, and this is the main website. So currently they have, I think you have here some kind of statistics about the let me, so sorry, the last website was the main website of this government agency called CNPq. That's an agency that promotes research in Brazil. So, and this website now that I'm showing to you is the Lattice platform, is the main page of the Lattice platform. So you have some statistics here. Let me see if I can show you something. So this is the current situation of the Lattice platform in Brazil. So I have a total of 2,700,000 resumes. So sorry, the page is in Portuguese. So just take a look on the graphs and on the pie charts. And as you can see, we have the whole country engaged in this platform, and mainly because the government imposed that all researchers that want to submit a research proposal to have funding for the government should have his Lattice updated in the platform. So it's a condition, it's a necessary condition to have any kind of money from government to have your resume updated in the large platform. That's the main reason I have so many researchers with their resume updated here. And it's a good coverage of the research in Brazil and how it works. So let me show you my labs. So we have here for the researchers, we can go, we can use the website to update our information. So just to have an idea of the interface, we have this interface here that we connect, and then as you can see, I can update all my information. So if I want to, for example, I have just came from events. I can register here the participation in an event, or I can register an article published in a scientific journal, or all kind of outcome from research. Of course, we have all kind of we have people that like the platform, and of course we have all kind of complaints about the platform. So people don't like because all sort of things. But in the end, I believe that this is very interesting data about the whole country, and of course it's it's very useful if you want to have a general view of what kind of research is doing in Brazil. But of course, the fact that the government is driving the whole process without any share of ideas with the institutions, with research institutions, and this makes the process a little bit difficult to believe that we will have a good future. But I think that was a very good initiative from the Brazilian government 10 years ago or more when they created this platform. So back for the interface, just to have to give you more ideas. So here you can see that I can for example, for this book, I can put all kind of information of the book, and it's a very with a lot of fields. It's a very complete form. So you have the authors, keywords, all sort of things. So and that's it. So this is the platform. People go to the website, update their information, and for the government, that's it. So, but how can we use this same information in the institutions? So the universities and research institutions want to have their information about their own researchers, and that's a big problem because they are kind of very closed for that. So by now, the only way that you can have the data is to, suppose that you want to have the information about myself. So here we have this page that I don't consider is a very clean presentation of the information, but it's a one page with all my resume, and we can download it as an XML file. So if I want to download my resume, I can click here, but then I cannot do it in a batch mode. As you can see, we have to manually enter this code to have access to XML file. So it makes hard to people that want to actually browse the whole website, getting data about the researches and constructing data sets about different research. So I can't consider this open data, mainly because of this restriction to access the structured data. And besides this link, and institution can also sign a contract with the government, with CNPq, and allow one specific server of the institution to have access to a web server in the CNPq server, and then from this web server we can get all the resumes of researchers that said in their resumes that they worked to that institution. So, and that's the way that I get the XML files from my institution. So let me show you how these XML files are. So this is an XML file of my resume. So basically all that information that we saw in the interfaces here. Let's see one specific article. So here's an article. So basically, the XML file has this general template. We have this basic data about an article. Then we have a detailed information about the article. We have the authors. Oops, sorry. Okay, then we have the authors. Okay. Keywords. Areas of the research, so knowledge areas, and that's it about an article. So we have articles, theses, we have all the XML file cover all the information that we have input in the website. What I made from that. So from that I developed it, and actually my work with this data started even before I met with VIVO. So the idea back to 2010 was to construct my own website visualization stuff to present that data. But then I'm now quite convinced that the way to go is to ingest all this data inside VIVO and take advantage of all the VIVO infrastructure to show this data, to present this data for the user, and allow people to complete the information with their specific stuff that Lattes platform we cannot put there, we cannot hazard there. So I developed this. The main files here in this GitHub repository is this Lattice XSL, is a XLT transformation, and I also keep updated a DTD file with the current structure of the XML file. So this is funny stuff. So the Lattice platform, when they began this, I think we have a page here to talk about this. But in the beginning of the platform, the government put together a bunch of people from different institutions, and they create a kind of a group to work on the specification of this XML file and this model. But after 5 years, they just stopped to have this group contributing, and the government took control of the whole process. So and by that time, they just stopped to update the DTD of the XML. So what happens to me is that once or twice a year, when I retrieve the resumes, I have to update the DTD because I discovered that they just changed the format and didn't make and didn't announce anything about it. So I have to maintain my own DTD because the government couldn't provide to us the DTD update. This is a kind of a shame from the whole idea of the platform. But so I have this. I keep my own version of the DTD, so I'm able to. Let me see what's happening here. Okay, so I have my own DTD to.
Hey Alex, why do you use
update.
why do you use a DTD instead of an XSD?
Because it's never thought about. I mean, it's just a basic validation to have an idea if the tags are okay. If I have just new tags, so for me it's working. I don't need anything more expressive than a DTD. But yeah, at some point I'm considering to have to migrate DTD for a schema and things like that. So, but it works.
Gotcha.
For what I need, it works. And somehow this keep me closer to the original file that the government distributed. So there's a way to talk with the community and make everybody knows that in this Git repository you have the updated file, but it's not something that I created. I want people to understand that this is just an updated version that the government should provide to us, but I'm doing their work.
Gotcha.
And second is this transformation. So we have I have this transformation that from an XML file produce an RDF file. So this is the main code that I developed, I think, 4 years ago, and makes the most interesting work because it actually transformed the XML file to RDF. And we have this transformation. Well, I cleaned up this stuff a couple of times, so I think now I can consider this a very stable code, and basically to take care of transform articles, books, chapter, all kind of information related with technical production outcomes of research. And I also get data from the researchers and their skills, their interests in research areas, and I think that's it. Oh, I also get the journals, information about the events, the conference and workshops and things like that. That's it. And as you can see in the top, I use mostly all the ontology and vocabularies that the VIVO ontology use. So that's why last year when I made my presentation at the VIVO conference, I said that I was not too far from the VIVO ontology because the way that I encoded the information was very, very similar. So the only thing that I had to do recently was to make some small transformations that actually create the instance that connect the article to the author of the article, or a person to the department. That classes that VIVO ontology has called authorship, and this. I think that someone told me that the name that they used to that, those classes that make the connections between the person and department, person and publication, things like that. So that's the only thing that changed compared with my model. Okay. So I show you the XML file, I show you the transformation. Before talk about the space, let me show you the final RDF. So once I have one RDF for each XML file, I put all of them together inside a triple store. And then I have this triple store. For my institution, we have around 500 researchers. We have this size of the triple store. As you can see at the top, 1 million statements. And the classes are this one. So thesis, area, document, things like that. This interface that I'm showing to you is the web interface to a Lego graph. It's called a web view. And this web interface is very nice because I can make a query here, and also I can browse the data. So I can just navigate to the data as you can see here in my screen. So I go from the author and then go to the publication and keep navigating the whole data graph. So that's a very nice interface. I'm not aware of any other interface similar of that to other triple stores. Do anyone know any similar interface for other triple stores?
Sesame has something a little bit like this, but doesn't seem to have as many features as this.
Yeah, I think they don't have this easy way to navigate between because here I can navigate not only the value but also the properties, the classes. I have this is very flexible. This interface is very flexible. I can submit a query, I can submit a script, and I can have a text query, so I can just ask for make a text query and find all the triples that has in some reference to the string that I query. So it's a very flexible interface. And that's it. That's the way that I put all the information together from resumes. But well, I will talk later on what are the next steps. But first, let me present another source of data that we have is our digital library. So we use here this space, as a repository for digital library. And inside the digital library, we have one, the space called it community. So we have one community for each school or department. And in most of the departments we have, in almost all of them, we have the collections with theses and dissertations of defended in the department. So here we have, for example, one register about one specific thesis, PhD thesis defended in this school. And of course, given that that example, we can conclude that this information about this specific thesis should come up from digital repository, from the space, from the resume of the advisor, and from the resume of the author, the student, and maybe from the resume of the people that were present in the, what's the name of that? The people that participate in the process to approve the work. So after put all this information together, I have to work on what I call the deduplication of the record, precisely because of that, because we have data that come from different sources, and the data is about the same entity. So, and this is a very a good example. So we work with these two sources of data, so DataSpace and these XML files. Now I'm talking a little bit more about the workflow for each of these sources. Let's start with the LATS files. So as I said, choose XML files. I have already showed the transformation, the DTD that I used to validate it. For validation, I use the what's the name of tool? XML lint, I think. It's the utility to validate XML using a DTD. And for the transformation, I think the name of the tool is a proc. Yes, it's a standard Unix tool that people use to run XML. I have already shown you the RDF inside the level graph. Just to talk about performance, to load 487 files, it took me 2 minutes in a Lego graph. So a Lego graph is a very fast type of store. One of the things that I really would like to try is to have a Lego graph connected with VIVO, but then I need a way to turn off the reasoning inside VIVO, because I would like to have a Lego graph doing the reasoning process, because also it's very fast to it and it can materialize the results. So I think I could have a very good performance if I put a Lego graph to handle the data and the reasoning. Does anyone have any other number compared with that to load in the triple store? So what do you think this is a good number, as I'm said, or I'm maybe I'm wrong and people have better numbers to load this kind of data to a triple store?
No, that's a pretty fast number.
Yeah. So when I start to work with the data and prepare it to ingest into VIVO, of course I need tools to explore the data to understand what are the differences between my model and the expected model by VIVO. And as I said to you, one very interesting tool was the web interface of Lego graph. But the other interface that's very, very nice is this tool called Groove. Let me show you Groove. So Groove is a tool for Francis. I have just downloaded the new version. So if you want to have more information about this, is here. France Inc. and Groove is the RDF browser, and unfortunately Groove, I think it's work only with a Lego graph. I'm not sure if it works with other triple store. Let me see. Maybe they say something about this here. No, I'm not sure. I think it works only with Lego Graph. But it's a very nice tool. Let me show you a little bit. So this is the interface, and the first thing I have to do is to, of course, to connect to a triple store, and I can connect to a remote triple store. So let's just connect to this triple store that I show you in the web interface. So this is the same triple store that we navigate in the web browser, but here in Groove I can do things like that. So let's start showing a specific node. So I can insert a node here in the screen using the address, the label, or the type, for example. And if I select the type, what he's showing me is all types that he found in triple store. If I select article, now he will show me a different instance that he found in triple store of that type. So for example, let me find just one specific instance here. So, okay, so I have here one node that's of type article. And now I can select what kind of properties I want to navigate through. So I can select the properties that I'm interested to use to navigate through the data. So let's say that I want the creator and the title. Now I can just press F to explore the connections, all the connections from that specific node that I'm selected, using the properties that I said that I want to navigate through. So now he's showing me the title and the author. Since I'm now in the node with different type, he's using a different color for that. So it's person, it's a literal, and the person. Now I can, once again, I can show that dialog box that will allow me to select more properties that he identify that could be used to navigate the data. So, for example, I can put name here, and is referenced by there's a proper. Well, I'm just selecting some of just to show some examples. So, since now I select the name, I can again use F to explore and find the name of that guy. And since I have already selected creator, if now I select this node author and press F, now it will explore all other articles or publications that has this guy as author. But I think that's the only one that has this guy as author. Now I can use this another properties. So I think you got the idea, right? So this is a very nice tool that we can use to browse the RDF and explore the RDF, selecting specific properties that we want to navigate through, and we can also make queries here. We can see a specific resource as a table, so we can show the resource as a table. We can go back to a graph view. We can make queries, Sparkle queries, and then we can show the result as a graph or a table. So this is a really interesting tool. I think this is the tool that if I have to choose another triple store, I will miss a lot. So, and actually I use this tool the tool that helped me a lot to identify the difference between the models and create all the code that I needed to transform, to prepare my data to load in VIVO. So that is good. Now I should ask money for France to make this presentation to you. Okay. As I said, the first thing that I need to do is to make the duplication of records. So, and to the duplication, I use I program and list the code. So my code is basically I have a kind of a, for list, this could be a packet, like a Python packet could load. So I have one specific packet in common list called VIVO, and I put all the code related to this project inside this package. And the duplication is my code to remove duplication of agents, areas, journals, and things like that. So just to show you some example of the code. So this is the main function to remove duplication of person, so agents. So basically, the code is it's based on the idea of a very well-known algorithm called to the problem of disjoint sets. So the basic idea is it makes a query. So here's the first thing that is executed. It makes a query in the tuple store, and this query is a query that retrieves all the names of all the researches, all person, all nodes of type person, and it returns for each one it returns the address, the ID when it exists, inbox when it exists, and a name. And I put all of these instances in a list. So I have this auxiliary function called a list to agents. I run the Sparkle, and I use this function that's defined here. I use this function here to for each result of the query transform it in an instance of a class person. So this is a way to have instances and classes in Common Lisp. So person is a class that I declared here, and I use it in that code to create an instance of a person. Okay, so given a list of all nodes of type person that I found in the tuple store, I submit this list to this function disjoint stats1. So disjoint stats1 is this function. It basically gets the list, the two auxiliary functions. That the one is the function used to test if two instances are equal, and the second one is the function that will be used to extract the key of one specific instance. So these parameters make my code very modular. So I can pass to the same disjoint sets. I use the same function to normalize agents, areas, journals, and things like that. I just have to pass specific functions for what will be the function to compare the instance, and what will be the function to extract the identification of that instance. And that's the whole idea of the code. I'm just showing this because to give you some idea of how it is to program in Common Lisp. So the good thing about Common Lisp is that the performance is a good thing. Once it's compiled, it's very fast. It's much faster than Python, for example. Another very interesting thing in Common Lisp, in particular in Allegro Graph, is the fact that we can make prologue queries. So we can go to, let me show you kind of query I'm talking about. I think it's here. It's already open. So here I can make queries, not only Sparkle queries, but prologue queries. And prologue queries are very nice. I can let me show you something just to give you an example. So I can see, I can put things like so it's a simple query that get all the names of instance of type person. And the interesting thing about this is that these are not a string. So this is a form. This is a code. I can put it inside my code, and I don't like here, as you can see here. So I don't have to handle strings. I don't have to prepare a Sparkle that will be a string inside my code. It's actually part of the code is the query. So it's very similar of the idea of a C# link. I don't know if people are familiar with the C# feature to query relational database, but this whole idea of having the query as a first citizen of the code is very interesting, and I use it a lot. Although sometimes I need to use Sparkle because of the performance. The Spark engine is much more improved, much more fast than the Prolog query engine. Okay, so that's the code that I use. So the important thing here, just to after present some idea of the how common list look like, how common list looks like. The important thing here is about the logic of the whole stuff. So what I'm doing basically was to identify this list of a person that I get from the data set, identify which one are equal, given one specific test to identify to say to me what are two instance of person what I can consider to be an equal instance. So in this case, as you can see here in the code, I will say that two instances are about the same person if one of these things happens. So if they have the same URI, or if they have the same ID and box and finally the name. So the order here is important, because what I'm saying is that the first thing that happens here will be sufficient to say that the P1 and P2 are the same entity. It should be the same entity. And what I do when I discover that two resources are about the same entity is to connect them using this. I add a triple that say to me that one is same as the other. So I didn't actually change the data. I just add one more information to triple store that said to me, okay, this resource is same as another resource. Okay. So given that, I think I don't have time to talk more about this, but these two guys here are QuickLisp is a packet manager for Common Lisp. And this packet manager is very nice, very simple to use, and I think QuickLisp is responsible to make Common Lisp more modern. And people start to use again Common Lisp mainly because QuickLisp. It makes it very easy to handle libraries and download libraries, install libraries, and things like that. And another tool related to the Common Lisp is Lime. Lime is a mode for Emacs. So it's a kind of an editor, and also it provides me the interface with the interpreter and the compiler. And Slime has very nice features, like I can connect to a process that's running the server. So I can have my Amazon server running a Lisp process. The Lisp process in the Amazon server is connected to the triple store that's actually also running the same server. So the process and the Allegro graph is running in the same machine. And my editor, my Emacs in my laptop connects to the process in the server. So I'm able to interact with the interpreter running the server. So it's a very nice feature of Slime. Unfortunately, I don't think I have time to show you how things work. And for transformation, that's the point that I really would like to improve. For the transformation, I start using these rule files that let me show you. So I start with this kind of rule. So for example, this first one said to me that, for example, here, okay, it says to me that whenever I have an X that has a name and is a person, I should create, I should specify that actually this one is a faculty member in the VIVO ontology, it has a label, and is connected by this OBO arg20028 to a vcard instance, and that vcard instance also connects to other vcards for a name and for a name and title. So this kind of transformations is encoded as a rule, and that was my first step. So I started to construct these rules, and given that rules, I just have to execute this tool called the CWM. So the CWM receives RDF data, an RDF or NT file with the rules, and it produces a new RDF. The problem with this tool, and the reason that I have to abandon it, is because of the performance. So this tool doesn't have good performance. So for one individual resume, it works fine, but for the whole data set, it will take forever to run. But that was my starting point, and actually the approach to using these rules in the CWM tool to execute them was very nice to come up with the final queries, the Sparkle queries that I used. So these are kind of a debug environment to me. So I create the rules, I test them with a small file, and then I have just to transform these rules in Sparkle constructed queries. And this is very nice. It's very easy to transform each rule will turn to be a Sparkle constructed queries, and there's almost one-on-one transformation. So I still use these entry files with rules to debug, to test the transformation. Once I have as I said, once I have the rules and I'm quite happy with them, then what I did was just construct queries to make the transformation faster. So for example, let me show you one specific query here, for example, authorship. So this Sparkle 101 construct query that just produced for it. It says that if you have an instance of a class article, book, thesis, or chapter, and we have a DC creator, because in my model I connected directly an article to a person using a DC creator. And if I have this pattern, what I need to do is to create an instance of authorship. But as you can see, one not good point of this workflow for now is the fact that it creates a blank node. So in the end, what I need to do before I ingest it into VIVO was to serialize the whole triple store, looking for the blank nodes and transform them to a non-blank node with a general identifier, a random identifier. And that's something that should be improved, because, for instance, the fact that I'm using here blank nodes gives me a very huge problem. Once if I execute this query twice, I will double the number of authorship instances in the triple store. I don't have control over not creating duplicated instance of authorship. So that's something that I need to improve. I have two ways to work on that. The first one is to actually try not to create a blank node, try to create an actual node with an address. And I'm not sure if it will be easy to do, because I don't have any good identifier for that. But I'm open for suggestions if the people that listen here have an idea. Or I can try to make some more smart code to in the end of the process to clean up the duplications of the blank nodes. So I don't know. I have to work on that. I still have to think about this. And that's the first the problem that's why I wrote here problems. Of course, another thing that I like to add in my workflow is some kind of a reasoning. So not just to produce new information, but also to validate the information. So the next step that I want to work on. And how much time I still have?
You get about, well, we end the call at 2 o'clock, so, but I'm happy to stay on afterwards.
No, that's okay. Let me just go quickly here. So just to say 2 or 3 words about the data space. So the data in the space I get them using this protocol calling OAI, so this Open Archive protocol. I don't know if people are familiar with that, but this is a very clean protocol to connect to a repository, digital repository, and extract data from it. So we have different tools to interact with a repository, use this protocol. One nice website is this one. This website allows me to browse a database instance. So if I put here the address of, I think we have here the address of my institution, because it saves the, well, no, it didn't save the address of my institution. But basically, I can put here the address of the space instance of my institution, and then I can interact with the protocol, making queries to the space. And also we have a bunch of libraries. This one is R, to work with this protocol in R, or Python. Since I don't like Python anymore, but prefer to use Lisp or R.
Did you just say you don't like Python
So let me just
anymore?
give you examples. Yeah, I used to work with Python a lot, but nowadays I just, after Python 3, I just give up to believe that Python is a good language to work with. Well, to be fair, the fact that I discovered Lisp also make my mind change. So I completely changed my mind after I start to work with Common Lisp. I can't imagine working with serious stuff in Python anymore. Maybe because it performs, maybe because some problems with the language, like the fact that Python is not very good to thread the parallel programming and things like that. So yeah, there's a very long discussion, but anyway. So just to give some examples here, of two nice things about this section is that I'm using two things here. So first, I'm using the R library to connect to use the R library of the OAI protocol, the Open Archive protocol. I use it to connect to the database instance and get from the instance all type of metadata formats that this instance is capacity to give me. So how can I say that? The different formats that the instance could provide the data to me. So these are it says that it is able to retrieve, I could retrieve the information to the repository in RDF, in Dublin Core, RDF, or METS. And given that, I can make another query for the same base URI and ask for all sets. So each collection of documents in the space, it's called by this protocol as a set. And I can retrieve all the sets with this function of the library, of the R library. And I can get the top of the top 10 or top 6, I think 6, 7 from this set. And here I'm showing the top of this top 5 or 6, I don't know. And then from one specific set, and now let me call your attention from one very interesting thing here. So as you can see in these blocks, I'm using R code, right? So each block here in begin source, end source, those lines are R codes. But the whole file is not R. The whole file is an org file from Emacs. And the interesting thing here is that, well, I can mix code with data. And actually here, since I'm getting some data that I want to use in another block of code, what I'm doing is I'm naming this block of code. And given that I provide this name, the data that the code produces also has this name, sets. And now here in the next block, I'm using this data to pass to the next block. So this is a very nice feature of org modes. So I should emphasize that org mode in Emacs are not just unedged or minor stuff for me. Those are very important tools in my workflow because of this kind of things that I can do. So I get this table, and I provided this table as data to this block. And this block understands this data, the variable called series now has the value of this table. And these R codes is able to get, here I'm saying to get this information here, the third line, first column. And using this one, I get all the records in this collection. So I have 31 documents in this collection. In each document has five metadata information. If I get one of these, just to show an example, I have the XML with all the metadata of this record. So this is the actual record of one document in the space. And that's so I don't use R to actually get the whole data from the dayspace, but R and the org modes are the tools that I use to understand the information, to browse the stuff, to debug the ideas, and then when I finally discover, okay, what kind of sets I want, what's the format that we work with, then I get the data using the Python library for that moment, but I'm start to write my own library in Common Lisp to connect to the space and retrieve the data. Well, I think that's it. Let me see if I have something more to add. No, I don't think it's okay. Okay. So as I said, just to finish, the future directions, we have the idea of develop this Common Lisp package to interact with this protocol. I just realized that I can't use I need to use this maths metadata instead of the Dublin core, and this is because the way that Dublin core is encoding. So they space using what they call this I think is Dublin core, specialized Dublin core or something like that. This is the way to put a contributor, and then it's qualified Dublin core. So they use this dot and other, dot and author to qualify the contributor properties, and the things that this protocol, the Open Archive protocol, couldn't understand that, and he just removed this qualification author. And then what happens that in my current workflow, I found this bug. I don't have ways to differentiate between an author and advise and the other contributors, because I lost this last part of the field name, what this space is called, the qualified field of Dublin core. So I just realized that we have to work with different metadata, and maths should work better, because this maths format give me the role. The last part of the property name is what it calls the role. So I have the complete information that I needed to produce the right RDF to ingest in VIVO.
Does anybody have any questions for Alexander? I know we're running a little long, but this was such a great presentation. I wanted to let him go, but I wanted to make sure that if anybody had any questions.
Yeah, well, I just finished, so I'm completely open for questions. I'm so sorry to not prepare myself better.
No, thank you very much for giving us this great talk. It was a lot of information.
Yeah. I have to confess that I made this presentation during a flight. I'm just returned to Rio today from an event in the south of the country, so I have a little time to prepare this and prepare myself to make the presentation. So I'm so sorry for this.
That's quite all right.
But
anybody have any questions?
Very interesting. Yeah.
Go ahead, John.
Plus, we were inspired to see a presentation in Emacs.
Yeah, I want to show you org mode, and then I realized that the best way to show is to use it during the whole time.
Can you share the file with us? Because you went so quickly, so we cannot follow.
Of course,
So
of course. Let me just, I will just need until the end of the day to see if I don't have any protect information here, but it looks like it's okay to me to share this data. Actually, I would like to share and hear from you some ideas, because maybe in some parts of my workflow I could improve it. As I said, I'm still not quite happy with that. I want to things to. Well, one thing that I really like, I'm really working on is about the duplication step. The bad thing about the current deduplication is because it's very specialized for each kind of resource. So I have one function to deduplicate a person, then one function to deduplicate areas, one function for the journal, and that's not the way to go. I want things that are more declarative. I want to say to the whole graph, I want to say, well, okay, I have to say, I will take two resources to be the same when they are the same kind, and if they are of the kind person with their name are equal and something, that's okay, having to specify the criteria of identification for each class. But I really would like to have a more general way to browse the graph and put together that nodes without having to run one query for each type to deduplicate the resource. Were I clear here? Do you understand the point? I mean, the whole point is to make the process of the duplication more global.
Yes.
And declarative.
Right. You had separate functions. That was one of the questions I had, is have you shared that deduplication code? It's interesting. I was trying to stop myself from reading about the disjoint dataset algorithm you used. So
I can share. I can. Yeah. I'm planning to submit, and I can do this today. I can submit this Lisp package called VIVO. I can submit it to my GitHub, so cool. you have access to that. That's okay. But as I said, I'm still working and have a better, because the duplication stuff is also interesting. Because, for example, imagine that we have we are the duplication person and also article, but depends on where you start the process, right. So you can have better results. Because if I deduplicate first the author, then I have more clues to the duplication some articles that the creators are those persons that I have just deduplicated before.
Right.
So depending on the order that I run the process, I could have more clues to the duplication other instance. That's why I want to end up with a better code and a more global way to the duplication resource. But at least this current code that I'm using is quite fast, and I worked with that during the last 2 years, I think. So that was the last version I have, and it's able to deduplicate all at least 4 or 5 different kind of classes in less than 1 hour.
Other questions for Alexander?
Just want to make a quick comment. I put it in the chat window. This is Alex in Boulder. Alexander, you mentioned that the graph tool only worked with a Lego graph, but it looks like there's a beta feature in the newest release that will work with triple stores. Is that something you already looked at, or?
You're talking about putting VIVO to talk with the Lego graph?
No, with just the graph, that graph tool that you were showing earlier.
The Groove.
Yes, Groove.
Yes. Okay, and can you repeat what is?
Well, it says basically what Alex is saying is that Gruff has a new beta version out, which will let you connect to other Sparkle.
Nice. Yeah. As I said to you, Alex, I'm not sure if I can connect to other triple store. They just released this last version of Groove last week, and I didn't have time to explore the whole new version. So it's nice to know that now they can connect to any specific Spark endpoint. Because if one of the things, well, the most interesting tool that I think that I presented to you here today was Groove. Groove is very nice. You should make some tests on that and use it because it's a very nice tool. It's helped me a lot to identify the model, to identify the difference between my model and the Vivo. It was essential to me.
Thanks.
Any other questions? Well, if you guys think of questions after the call's over, please feel free to email Alexander or me or Ted
Of
Law,
course, yeah.
and we'd be happy to get them answered. And again, I can't thank you enough, Alexander. I know you're so busy, and I really appreciate you taking the time to give us this talk. It was fantastic.
Thank you. I will put the links in this Google Docs in the end of the day, so people can see the codes and share with me ideas.
Fantastic.
Thank you very much for your time.
No problem.
Thank
Ted,
you.
Thanks,
Ted,
Alex.
Ted, do you have
Thank
anything
you.
to wrap up with?
No, it just if you're interested in any of those tools that we talked about today, just send an email and maybe we can have a follow-up that dives into a little deeper into one of these tools.
Yes, of course, yes. That would be very
Absolutely.
nice. Maybe during the Vivo conference we can find a room and talk more about these tools, of course.
Yeah.
Absolutely. All right. Well, thanks everybody. Thank you for staying around so long. We had the whole audience stick around for the whole time. That was pretty fantastic. And as always, we'll see you in 2 weeks. So the next call is on the 5th of May, right, Ted? No,
1 week later.
the 12th. No, the 13th. 13th of May.
Okay.
We'll see everybody on the 13th of May. All right. Thanks a lot.
See you.
All right.
Bye.
Bye everyone. Thanks.